We're going to take a look at an ideal gas law example problem. Now, sometimes the hardest part of these problems is making sure all your units are correct. So let's read it. Determine the volume of 1 mole of gas at 20 degrees Celsius and a pressure of 100 kPa. So we're looking for volume. It's our unknown. Ooh, that's kind of thick. I'm going to change that. We do know that the number of particles is equal to 1 mole. We also know that the temperature is 20 degrees Celsius, and we know the pressure is equal to 100 kilopascals. And we know the ideal gas law says that pressure times volume is equal to the number of particles times the gas constant R times the temperature T. But be careful, because R is a number. It's 8.315 joules per mole Kelvin. Alright, now think about this unit for a minute. Joules measure energy, and 1 joule is the amount of work you do when you use 1 Newton force to push 1 kilogram, or a 1 Newton force acts through a 1 meter distance. So a joule is equal to a Newton times a meter. But remember, a Newton is equal to a kilogram meter per second squared, which tells us a joule is really a kilogram meter squared per second squared. Okay, so we have kilograms, meters, seconds. So we're going to need everything to be in terms of kilograms, meters, and seconds. And remember, a kilopascal is not. A kilopascal is 1,000 newtons per square meter. So we have to deal with this K. So I'm going to go ahead and rewrite this as 100,000 newtons per square meter, just because that's a kilopascal, right? And now I have newtons, which matches this, and square meters, which matches, so we're good to go. The other thing is this is a Kelvin. This is a Kelvin, not a degree Celsius, so I have to add 273 to this to get 293 Kelvin. Now all my units match, and I should be able to solve this. So I'm going to put in 100,000 newtons per square meter for pressure times V is equal to 1, because I have 1 mole of gas, 1 mole times R, which is 8.315 joules per mole Kelvin, times 293 Kelvin. Alright, so my kelvins cancel my kelvins, my moles cancel my moles, and now I just got to do a little bit of algebra. So if I do this right, I'm going to have 100,000 newtons per square meter is equal to 293 times 8.315, and this still has some units left. It still has a joule left. Remember, this is a joule is a newton or newton times a meter. So now when I divide this over, oh, and my V is still over here. When I divide this over, I get V is equal to 293 times 8.315 divided by 100,000. Now, my units up here are newtons times meters, but since I just divided this, I have times meters squared per newton times meters squared per newton. Well, that newton cancels that newton, which is good, and I'm left with whatever this number is in meters cubed, which is good because I'm looking for a volume, and a volume is a cubic meter. So once you have your units in and you made everything in the right units, then this is just a pretty straightforward algebra problem. The trick is to be careful with your units.